Chapter 3, Matter and Energy. So here's a picture of a room. Everything visible in this picture is made of matter. Different kinds of matter are related to the differences in the particles, the atoms and the molecules that compose the matter. Here there's water in this bottle. It's a liquid, you can drink it, it's refreshing, it sustains life. Here's a golf club with graphite in the handle. It's very lightweight and strong. You couldn't drink that, right? There are differences in properties between the graphite in the golf club and the water in the water bottle. Those differences have to do with the atoms and molecules that compose the substance, that compose the matter. Well, what is matter? There's all sorts of puns about this. What is matter is a different question than what is the matter, right? We're talking about what is matter. Matter can be defined as anything that occupies space and has mass. I came across a picture of this t-shirt on the internet. You occupy space, you have mass, you matter. I like that. Some kinds of matter are easily visible. Name a couple kinds of matter. The table. How about another one? What about your hair? Is your hair matter? Sure. It has mass. It occupies volume. Some of us wish it had a little more volume, but whatever. Other kinds of matter are impossible to see without magnification. You think of some matter that we can't see with our eyes. Air. This room is full of air. Thank goodness, because we need it to breathe. Can we see the air? No. The atoms and molecules that make up the air are too small for us to see. So we can't see air. A helium balloon, right? You can tell there's something in there. Something had to make the balloon expand. If you let the helium out, can you see it come out? No. It's too small, right? So helium. There's lots of examples of matter that are too small to see. Matter often appears smooth and continuous. Look at the table on your chair there. It's pretty smooth, right? It looks like one solid piece. But it actually isn't. It's composed of atoms. So if we were able to zoom in, we'd see that it's essentially composed of a bunch of little spheres, incredibly little spheres. You guys ever been to Legoland? No, some of you have. Or been to downtown Disney and seen the Lego store, and they've got all these cool sculptures, right? If you stand far enough back from one of those, it looks like the real thing almost. But then you get up close to it and you realize it's made up of a bunch of little tiny Lego bricks. It's the same idea with matter. If you get in close enough, you see that it's actually these individual little building blocks that make up something. It appears solid and continuous to us because the particles are so tiny. So atoms are submicroscopic. They're too small to be seen with a microscope. Sub means below. They are the fundamental building blocks of matter. So atoms can bond together to form molecules. A molecule is just two or more atoms that are stuck together. They form specific geometric arrangements. You could make a model of a molecule by gluing styrofoam balls together. But when atoms combine, they combine in specific arrangements. They kind of click into place. We look at the lid of a soda can, an aluminum can. If we were able to zoom in, we would see that it is composed of aluminum atoms, arranged in a particular order. So in some substances, like aluminum, the individual particles are the atoms themselves. In other substances, like this is rubbing alcohol, isopropyl alcohol, the individual particles are molecules. The molecules are composed of atoms, but each of the individual particles in this isopropyl alcohol is a molecule. So I showed you that picture of the kanji characters made out of atoms. Here's where we get to talk about it a little bit more. So a scanning tunneling microscope creates an image by scanning a surface with the tip of a little probe that has atomic dimensions, incredibly small. And so the tip is moved across the surface, and they monitor the current between the surface and the tip and keep it constant. And so the tip goes up and down as it goes over the atoms, and the computer gives us an image like this of individual atoms. It's distorted, it's not a clear picture, but it's the closest we can get to pictures of atoms. They appear cone-shaped because of distortion, but they're actually spherical shapes. Here is a scanning tunneling microscope image of a DNA molecule. So the DNA molecule is in yellow. Let's see, what would be a good color? Orange. No, not that one. This one? This one? So, you know, it's a little bit fuzzy, but here's the double, ooh, that's way too fat. Here's the double helix. You can actually see the double helix with a scanning tunneling microscope. So I found a couple of really cool videos about this on YouTube, and I'm not going to take time in class to show them to you, but I'll put them on the playlist, and you can watch them yourself if you're interested.